In this video, we will learn about the use of vectors in MATLAB. So first, we need to know what vectors mean. So a vector is a one-dimensional array of numbers. So that could be rows or columns, and it should be enclosed with square brackets. So so you need to know the difference between row vectors and column vectors. So row vectors, like what you see here, so that will be, you can see it's enclosed with square brackets. And to create a row vector in MATLAB, you need to separate the numbers with the space, or you could separate it with comma. So either one of them, it should work for you. And we will demonstrate that in MATLAB. To create a column, then you have the only difference, you need to use semicolons between the numbers, and that's important to remember. So for row vectors, we use a space or comma. To make a column vectors, we put semicolons, and these are the elements, and we'll talk about this later. So that the length of this vector is 5. So 1, 2, 3, 4, 5 elements, and each element has an address, and they start from 1. So this is element 1. So this is CV1, CV2, CV3, CV4, CV5. The same thing for row elements. So each element, it has a length. So the length here is the number of elements. So we have 5 elements, and each has an address. And that's important because later we could just ask for a certain element. So if I want, in this case, like the 4th element, I could just call that 4th element, and we will learn how to do that. Another way of creating vectors, if they have constant spacing or steps between the element and another element, we could use the colon. So this is the format. You put the first element, and this is the last element, and this is the steps, how far do you want them. If you don't put that, it's okay, but the default will be 1. So in this case, we have steps of 0.5. So this is 0, 0.5, 1, 1.5, and until you reach to the 2. So that's kind of a handy way of doing that. Is so imagine you want to create a vector with 1,000 elements. So instead of just typing them 0, 0.5, 1.5, you can just put 0, 1,000, and just put 0.5, and then MATLAB will create the element for you with the constant spacing of 0.5. You could put that like 2. Let's say if we could go from 0 to 10, and if you put 2, then it will be 0, 2, 4, 6, 8, 10. You could put that negative. So if, let's say, we could start with 10 to 0, and we can go to -1. So this will be, the element will be 10, 9, 8, 7, and so on. So remember how to create that, and again, we are going to use this kind of format of creating elements very often. Another way, if we know how many elements do we need, and we know the first and the last elements too, we could use line space command. So that's like, this is the array. We just give it any variable name, and this is the last one is the number of points that you want, and then this is the first element, the last element, and then it will create a total of 5, and with the fixed spacing between these elements. So you have to know the difference between the colon and the line space. So with line space, you mainly the limit, you know how many elements do you want, with the column, you know how many how big is the step that to go from one element to another element. Let's demonstrate in MATLAB. So as I said, to create a row vector, you just either like in this case, you put the numbers with space between them. So that's like this. Let's like this is a row vector with 5 elements. So if we run it, so you can see RV, which is kind of just, you can call it any name. So this is just for row vector. So you could name it, but just remember this is a case sensitive. So RV capital is different than RV small. And these are, you can see they are row because they are in a row. And as I said, the other way you could put commas. There is no need for that. Just you need to know that comma and space will give you the same results. So if we clear that, and if you run it, you get exactly the same answer with a comma or with a space. And then to create a column vector, you need to remember you have to put semicolons between the elements or the numbers. So that's I just call it here. CV stands for column vector, but you could call it any name you want. So if we run it, so you can see the difference now. It's a column vector, and it has 5 elements. And you can see this is CV1, the first, second, third, fourth, and fifth. We could verify if a variable is a vector using a command is vector. So we could check if we have a command that we don't know, is it a variable, like if it is a vector or matrix or something else, or logical variable, we could check that. So is this a vector? We just put it there. And if we run it, so you can see the answer was 1, logical 1, which means yes, it is CV is a vector. We could change row vector to column vector. We call that transpose. Maybe we could put the hyphen there next to it. So like by doing that, we change the row vector to column vector. So this is a row vector, then A will be a column vector. Let's run it. And then if we do B, we can transpose A, then we bring it back to the original format. So here it is. Here is A. Sorry, here is the RV is a row vector. A, because we transposed it, and you can see it's a column vector here. So maybe this will reverse. And we could do the same, like now we have A. If we transpose A, we get the row vector again, which is kind of, you can see here B is a transpose of A. As I said, we could create the vector using the column there. So this is kind of the first element, this is the last element, and we need them to be spaced with 0.5 increments. So if we run it, this will be 0, 0.5, 1.5, 2. And that's what you get. So again, if you change that, so let's say to 20, and if we need the increment to be 2, so this will be 0, 2, 4, 6, all the way to 20. So when you run it, 0, 2, 4, 6, 8. And again, you could make it negative. Okay, you can make it 10 to 0, and let's make it negative 2. So that will be 10, and the steps or the steps or the spacing will be negative 2. So 10, negative 8, sorry, 10, 8, 6, 4, 2, and 0. So 10, 8, 6, 4, 2, and 0. So that's kind of handy way of creating. And the other method, we call that line space, which is, again, we know what's the first element, the last element, and what's important is the number of elements. So in this case, we have 5 elements, and we know the first, we know that the last, and this will be spaced equally spaced in the remaining ones. So if we run it, so you can see the first one is 1 and the last one is 10, and we need to space them so that they are a total of 5 elements. I know this is kind of a little bit more confusing than the colon, because again, MATLAB has to space them so that they are equally spaced and making sure we keep the number of elements to 5. So this is why we get fractions here. Another application, sometimes we need to combine row elements or column elements, and the way to do that, we call that concatenate or append. So let's say if we have a row vector 1, A1 has 3 elements, A2 has 2 elements, we could combine the two just by putting them in a third vector, or and mainly just putting the first and following the second one. So let's run it. So you can see this is the first and this is the second, and now A3 just combine the first and the second. So that's important to remember. Again, you could, if you do it the other way, let's say if we do it, it's like we do A4. If we reverse them, if we run it, so you can see now they are different. Like we put A2 first, then A1 compared to A3. So that's the way you put it. Then the other one will be appended or maybe added to the end of the row. We could do the same thing with a column, so we just make it a longer column. So if we have a column, you can see this is a column vector because we have a semicolons there. So we have 2 column vectors with semicolons. Then we can append or combine the two into one. So we will get a longer column vector. So 1, 2, 3, 4, 5. So this should be the answer because we append these two together. And you can see that's A3, just combine the two together. And here is A2 and A1. And we could do the same thing, like could change this to A4. So if we do this, you can see A2 will be listed first, which is the 4, 5, then 1, 2, 3. So the way depends on how you arrange them. So let's run it. And the very important aspect of vectors is the index. As I said, this is the first element, second element, third element, fourth, fifth element. So we could call one of the elements. So it starts from 1, not 0, because some programming languages, they start from 0, the index, like the address. So this is element 1, element 2, element 3, element 4, element 5. And we call this the length. We'll talk about this later. So I could just call element 3. So if we run it, so these are the E, and element 3 is the third element. So if I call element 3, I'll get 12. And let's see if I call E4, which one should I get? So 1, 2, 3, 4. So I should, if I run it, I should get the 24. So that's what we got there. And sometimes we could call more than one element. So we have to use like we do with Excel, we have to use the colon. So this is I'm calling element 2 to element 4. So the answer for this, so element 2 is 9 and element 4 is 9. So this is saying this would call these 3 elements 2 to 4. So 9, 12, 24 when I ask that. So this is sometimes you only need to look for certain elements, and we'll do that in the homework, so we can call one element by itself. So let's run it and see if that's what we get. Yes, so that's the E, and you can see when you select, if you index like 2 to 4, you get 9, 12, and 24, which is element 2, element 3, and element 4. If you just put the colon, that's all the elements. So just keep that. I mean, in case if you need to use that, so you can see if a colon means all the element. We don't use this very often with vectors, but we talk about matrix later. So when you see the colon, in the row side or the column side means all the columns or all and that has different application. Okay, let's switch to what can we do with vectors. So we could add numbers to them, scalars to them, so we could subtract. But again, we could add a vector to vector, we subtract vector to vector, but we have to pay attention if the vectors, when it is vector to vector, we have some restrictions that we will learn about because that's stepwise. But let's first do the simple ones. So if we have a row vector 1 to 5, and this is mainly we have make another vector which is row vector, we add 2 to it. So mainly this will just add 2 to each element of the row vector. So the answer will be, like in this case, 3, 4, 5, 6, and 7. So you can see the original row vector 1, 2, 3, 4, 5, and the new vector, which is B, is 3, 4, 5, 6, 7. And again, sometimes we just need to do calculations. We add, subtract, or do other mathematical operations on vector. The same thing with subtraction. So like this will be the new vector. It will subtract like 3 from each element. So this will be -2, -1, 0, 1, and 2. So you can see that's the original vector RV, and then B was created by subtracting 3 from each element stepwise. Okay, how about multiplication? It will multiply again with any number. If we pick, then it will be multiplied. So 2 times 1, so we get 2, 4, 6, 8, and 10 when we run it. So that's mainly what we got there. So you can see when we run it, so each element will be divided by the. So that's if we have it the vector divided by the number. But how about if we try to do it the other way around? If we try to divide the element by the vector. So let's see what we get. So if we put 2 divided by RV, and you can see you get an error there. So we call that stepwise. So we have to put a dot there to fix it, and we will learn about this in another. So by putting that, we make it stepwise. So this will be like 2 divided by each element of the matrix there. So like 2 divided by 1 is 2, 2 divided by 2 is 1, and so on. But if you forget to put that, it will give you. Okay, with the exponent is the same. So that's RV to the power of 2. So then each element will be raised to the power of 2. 1 square is 1, 2 square is 4, 3 square is 9. But again, if you try to do it the opposite, it's not going to work. You have to do stepwise by putting that. So if we run this, you have to put the dot for this to work. If you don't put that dot, you get an error. So it has to be with the dot. So just if you put the dot, you can fix it. So now it will work. So again, so without putting the dot, you will get an error. It's not going to work as a step. How about the opposite now? If we want to do the number to the power of the vector, so to do it, like, let's see if we just do it without the dot, see what we get. So you see that you get an error that you need to put the dot there. So you have to fix it to make it stepwise, just to go from one to another. So by doing it this, so now this will be stepwise, like 2 to the power of 1, then 2 to the power of 2, then 2 to the power of 3. So if we run it, so you get 2, 4, 8, 16, and 32, which is 2 to the power of 1, 2, 3, 4. Okay, the next topic is built-in functions. We could use some of the built-in functions we learned about before to apply in vectors, like square root. So if you do that square root of RV, then it will find the square root of each the elements in the vector. So square root of 1 is 1, square root of 4 is 2, and these are the other. So you can see 1, 1.4, and for 4 the square root is 4, the square root of 5 is 2. So you have to remember this, the function sqrt, so that's the for square. We could, yeah, this is very handy too. We could, sometimes we need to look for the largest number. They could be different order here. So the function for that is max. So that's the same like what we learned in Excel. So the largest element here is 5. So this is what we expect to get. So max of RV, just get one. You get just one number, not a vector. So the largest. We could also look for the smallest is min. So that will give you the. So the min will look for the smallest element, and you can see you get as 1. We could also find the standard deviation, the mean. So like these are common functions that you need to remember, like the mean. So just look for the average of these elements. When we have a vector, sometimes we don't know how big is the vector. So we have a function that can look for us how many elements in the function. We call that length. Just tell you how many element is there. And we use that in programming. So we don't have to worry about counting the elements and make an error in counting them. We just use length of the name of the vector. So that one should give us an output of 5, which means there are 5 elements in row vector. Another function can do size, which give you mainly this is used in matrix. But again, like MATLAB, treat the vector as a matrix with, like this one, one row with 5 columns. So the size will be 1 row times 5 columns. So if you run it, that's the size. So 1, always the first number is the number of rows, the second number is the number of columns. And if that was a vector, if that was a column vector, it would be reversed, it would be 5. In some cases, we need to have a big like vector. We like to make changes to the elements, add, delete, subtract, so or I mean replace. Like in this case, if we don't need this anymore, if that's some element that we don't know, we can delete that. Just we know the address. So this is the second element, and just putting it with empty square brackets. So that will be removed, then the RV will be shorter. So let's run it. So you can see originally it was 1, 2, 3, 4, 5. Now the 2 is gone after we applied this. We could replace one element with something else, like if we have make an error. So instead of typing it from the beginning, let's say if element 2 was supposed to be 6 instead of 2, we can just make the correction. So RV2 should equal to 6. Like in this case, it will just replace the 2 with 6. So you can see now everything else stays the same, but the second element was changed from 2 to 6. Vectors are not only limited to numbers, so also text is MATLAB treats text as a vector, but we have to put that in quotation. So like I could make a variable, call it school, Columbus State Community College. So that's so that will also they will take address. So this is element character 1, 2, 3, 4, 5, 6, 7, 8, 9. The space also is counted, 10, 11, and so on. So I could then ask for element. Let's run it. So you get Columbus. If you take 9 is a space, so 9, 2. So this is 9. Okay, we don't need 9, so let's start with 10. So 10, 11, 12, 13, 14. So if we go from 10 to 14, we expect to get a state. So let's run it, and that's correct. So this is what we got, a state. we could combine strings, like I could make variables for different string or different text, like first I just make it like Muhammad, last Merib, then for the name I can combine them, and also I put a space there. So that will make a larger text or string. So you can see first, last, and then the name is combining the two together. So that's kind of an overview of vectors. Okay.